Hi everyone, welcome to this LangGraph tutorial series. In this series, we're going to learn LangGraph from the absolute basics and gradually move toward building real-world AI agents and multi-agent systems. If you work with Python, AI, generative AI, large language models, or LangChain, or if you're simply interested in becoming an AI engineer, this series is for you. In today's video, we're starting with the fundamentals, and we'll answer 4 questions. First, what exactly is LangGraph? Second, why do we actually need it? Third, what's the difference between LangChain and LangGraph? And fourth, where is LangGraph used in real-world applications? By the end of this video, you'll have a clear picture of what LangGraph is and why it's become such an important framework for building stateful AI agents. Before we get into LangGraph itself, let's look at the problem it solves. Today, large language models like GPT, Claude, and Gemini can do impressive things. We can ask a question, give some context, summarize a document, generate code, or even have the model call external tools. But here's the catch. On its own, a language model is really just something that takes an input and produces an output. We give it a question, it processes that question, and it generates an answer. Nice and simple. This works great for simple use cases, but real-world AI applications are usually a lot more complicated than that. Imagine we're building an AI customer support agent, and a user asks, "Where is my order?" To answer that properly, our system needs to do several things. Understand what the user actually wants, identify the customer, call an order management API, check the order status, decide how to respond. And if the order can't be found, maybe ask the user for more details, or if the issue is complex, hand it off to a human agent. Now we've got multiple steps, and each one depends on what happened in the step before it. That's where things start to get interesting, because we need a way to manage these steps, decisions, state, loops, tools, and interactions. And that's exactly where LangGraph comes in. So, what exactly is LangGraph? LangGraph is an open-source framework from the LangChain ecosystem, built for creating stateful, long-running applications with language models and agents. The key idea is right there in the name, graph. Instead of thinking of our application as a single LLM call, we represent the whole workflow as a graph, made up of nodes, edges, and state. Let's break each of those down. First up, nodes. A node represents a single step in your application. That could be an intent detection node, a database node, an LLM node, a tool calling node, or a validation node. Each box you see here is one node, a focused, self-contained unit of work. Next, edges. Edges determine how we move from one node to the next. For example, after understanding a user's intent, we might move to a database search. And after that search, we might either generate an answer or ask the user for more information, depending on what we found. In short, edges control the flow of your application. And the third, and probably most important, concept, state. State is the information your graph needs to keep track of while it's running. That might include the user's question, the conversation history, a customer ID, an order ID, tool results, intermediate decisions, and the final response. Instead of every step working in isolation, your nodes read from, and write to, this shared state. That's one of the ideas that makes LangGraph so powerful. Let's tie this together with a quick example. Say we're building an AI travel assistant, and the user asks, "Plan a 5-day trip to Goa." Our graph might understand the query, search for information, and create an itinerary. But what if the search doesn't return enough information? That's exactly when we'd add a conditional edge, checking whether we have enough data, and looping back to search again if we don't. Notice what's happening here. This isn't just input, then LLM, then output. It has logic, it has decisions, it can loop, it maintains state, and it can interact with tools. That's exactly the kind of application LangGraph is built for. Now let's answer the second big question: why do we actually need LangGraph? If we already have LLMs and frameworks like LangChain, Why bother with another framework? The answer is that real-world agents need more control over execution. They need to handle multiple steps, decisions, loops, memory, tool calling, human approval, error handling, and long-running workflows. Here's a concrete example: an AI coding agent. The agent receives a task, analyzes it, and writes code. It runs that code, and if it fails, it analyzes the error, fixes the code, and runs it again. It might repeat that cycle several times before it succeeds. This is not a simple linear workflow. It's a loop. And LangGraph makes workflows like this far easier to model and control. Now let's talk about one of the most common questions people ask. What's the difference between LangChain and LangGraph? At a high level, LangChain gives you the building blocks and integrations for LLM-powered applications. Things like LLM integrations, prompt templates, tools, retrievers, chains, and structured output. LangGraph, on the other hand, is focused on orchestrating stateful workflows and agents as graphs through nodes, edges, conditional routing, loops, and agent orchestration. Here's a simple way to think about it. LangChain gives you the building blocks: the LLM, the tools, the retriever, the prompt, the memory. LangGraph gives you the blueprint that decides how those blocks work together in a stateful workflow. And here's an important point. Choosing LangGraph doesn't mean giving up LangChain. In most real applications, they work together. You'll often use LangChain components inside a LangGraph application. So, when should you actually reach for LangGraph? If your application is as simple as user asks a question, LLM answers, you probably don't need it. But the moment your application needs multiple steps, state, decisions, tools, loops, or human interaction, LangGraph becomes genuinely useful. That covers things like customer support agents, research agents, coding agents, data analysis agents, SQL agents, RAG agents, multi-agent systems, and long-running business workflows. Let's look at a few real-world use cases. A customer support agent can use LangGraph to manage the entire flow, from intent detection through to a generated response. An AI SQL agent can understand a question, generate SQL, validate it, execute it, and return an answer. A research agent can plan its research, search the web, collect information, analyze it, and produce a report. And in a multi-agent system, a supervisor can coordinate specialized agents for research, SQL, or coding to arrive at one final answer. Before we wrap up, here are 5 concepts worth remembering. A graph represents your overall application. A node represents an individual step. An edge controls how you move between steps. State stores the information shared across the workflow, and the workflow is the complete process your application follows, start to finish. In the videos ahead, we're going to build all of this step by step. We'll start with the basic LangGraph architecture, then cover state, nodes, and edges. From there, we'll connect LangGraph to an LLM and build a chatbot, add memory, and learn tool calling. Then we'll build full AI agents, covering conditional routing, loops, human-in-the-loop workflows, streaming, RAG, and multi-agent systems. And eventually, we'll bring it all together into a complete, real-world AI application. So, to sum up today's video, LangGraph is a framework for building stateful, controllable AI workflows and agents. It lets us model applications using graphs, nodes, edges, and state, and it's especially useful once your application needs multiple steps, decisions, loops, tools, memory, or human interaction. And remember, LangChain and LangGraph aren't competitors, they're built to work together. In the next video, we'll set up our Python environment and install LangGraph, then build our first LangGraph application from scratch. If you found this useful, hit like, subscribe, and follow along with the rest of the series. See you in the next video.